Here we go then for the second of the presentations for the Intro to Linguistics seminar. And this week we're going to be looking at vowels in phonetics. Now, vowels, unlike consonants, are quite tricky things to describe what's going on. Because if you think about it, with a consonant, you do something pretty definite with your tongue and your vocal apparatus, your lips and things like this, and you can fairly easily describe what's going on. Essentially, with a consonant, what you do is you interfere somehow with the airstream flowing through the vocal tract. And you do things to it like stop it from flowing and then suddenly release it, or create small gaps for the airstream to have to be forced through. And those sorts of things you can fairly easily describe. But with a vowel, there's very little interference with the airstream. So when you produce a noise like ah, or e, or oo, or something like that, you're not really interfering with the airstream at all. So obviously then it raises the question of, well, what is a vowel? What are you actually doing to produce vowel sounds? And how do you get different vowel sounds? Because obviously there isn't just a single vowel. There are lots of vowels in many languages. English has up to 20 vowels. So clearly we have to do something in order to create different vowels. But if you're not actually interfering with the airstream, what is it you do? So we'll spend some time at the beginning of this class just describing how it is that we make vowel kinds of noises. Okay, well, we'll start with the basics. All vowels involve voicing. We know that voicing is to do with vibrating the vocal cords. And to understand what different vowels are, we have to think a bit more carefully about what it means to vibrate vocal cords and what that does, what kinds of sounds vibration of the vocal cords produces. Okay, now this is a picture of John again. You perhaps won't recognise him because this time we've chopped the whole of his head off and now are staring down into his windpipe at about the level of his Adam's apple. So what we're looking at here is John's glottis. And as you can see, the glottis is a hole that basically comes out from your lungs and passes out through your mouth and nose. And across that, at this particular point, are these two folds or flaps of skin. They're a bit like curtains. You can sort of hold them open, like we've got here. This is John's vocal folds in an open position, but you can also close them together. And of course, if you close them, you're stopping the air flowing from the lungs, and that's how we produce sounds, consonant sounds like a cough or a fricative. With the cough, you close the vocal cords completely, build up pressure behind them, and then suddenly release them like a normal plosive. And with the fricative, you hold them closer together but not completely closed, and then force air through the gap, creating a hissing sound. Okay. Now, the other thing we can do with them is to vibrate them. Okay, and that's what voice is. Voice is the vibration of your vocal cords. How do you vibrate your vocal cords? Well, that's not a muscular thing. You can't create a vibration in them just by sort of moving muscles. What we do is we rely on another mechanism that is sort of based in the way physics works. Essentially, let's consider this diagram here as a representation of what's actually going on. This is the kind of the passage between your vocal cords, the vocal folds, coming from the lungs on the right-hand side and passing out into the oral cavity on the left-hand side. Now, under normal circumstances, the air that's inside that is creating an equivalent amount of pressure than what's coming from the outside of it. And so, in that case, those things are stable and they're not going to move because air pressure is equal on all sides. Now, if you hold your vocal cords loosely, in fair approximation to each other, so quite close, but not actually causing any pressure on them at all, well, things will stay the same just because of the equal pressure that's in around them. However, if you blow air between them, what this does, as a sort of like a physical fact about things, if you blow air over or between a confined space, what that does is it reduces the pressure on the inside of it. If you reduce the pressure from the inside, then the pressure on the outside is relatively increased. And that, of course, is then going to force these two things together. And they'll come together like that and close off the airflow. Now, because the airflow is now confined but still moving, that is going to create an increase of pressure on the inside. And of course, if you've got your vocal folds just loosely held together, there's nothing going to stop them from being forced apart, which will happen. Okay, so essentially, as you blow air through your vocal cords and they're held loosely together, they'll come together and then be forced apart, and then be forced together and be forced apart. Essentially, what's going to be happening is that those vocal cords are going to be doing this, i.e. they're going to be vibrating. Okay, and that's essentially how you vibrate your vocal cords to produce the notes that we hear in the vocalization. So ah is vibrating the vocal cords in one particular way. Okay, so that's what vowels involve. They involve this vibration of your vocal cords, but how come then there can be lots of different types of vowels? Why isn't there just one vowel if there's just one? There's a lot of vibrations. Well, again, in order to understand that, we have to understand something about vibration and how things vibrate and what that means. Let's take, for an example, a string of a stringed instrument such as a guitar or a violin or even a piano. A string is a wire or something stretched between 2 points such that if you pluck it or cause it to move by bowing it or something like that, it vibrates. Okay, and what will happen is it will vibrate along its length, backwards and forwards. Okay, now the vibration of the string causes air molecules around it to vibrate, which causes air molecules around those to vibrate, and basically sound is produced by vibrating the air molecules, which then reach your ears and you hear them as a sound. Okay, so that's what's going on. But strings don't just vibrate in this simple pattern, going backwards and forwards like that. What they do is they actually have a very complex series of vibrations, because not only does the whole string move backwards and forwards, but also what happens is half the string at the same time as the whole string is moving backwards and forwards, but half the string will go in one direction and the other half will go in the other, and that will vibrate. Now, that's going to cause another sound, different from the one where the whole string is vibrating. Essentially, these vibrations, because they are shorter pieces of string that are vibrating, are going to be faster. And the faster the vibration you get, the higher the note, the higher the frequency. So you'll be getting this frequency alongside this frequency. Get it going, okay? And that's not all either, because not only will the string vibrate along its half length, but it will also vibrate along a third of its length. so that the first part will go one way, the middle part will go the opposite way, and the last third will go in the other way, and they'll be vibrating at the same time as it's vibrating along its half length and along its whole length. And not only that, but also quarter lengths will be vibrating too, and sixths and twelfths and eighths and sixteenths. And all of these vibrations are going on at the same time, all of them producing a very complicated pattern of vibration. So your string is actually vibrating in a very complex way. That's why the sound you get from a string instrument is a rich sound, because it's not just a single pure note. It's a lot of notes all superimposed on each other. Some of those are going to be louder because they involve more vibration. The lower the notes are going to be louder there, and the really small vibrations of the strings are going to be quite subtle, but they all contribute to the overall sound. Now, if you think strings vibrate in a complex way, then you haven't looked at the vibration of the vocal cords. They vibrate in a really complex way along the lengths of those vocal cords, and therefore the sounds that we produce with our vocal cords are extremely rich, made up of lots and lots and lots of different frequencies, all superimposed on one another. Okay, so the human voice is actually a very rich sound with many frequencies happening at the same time. Now, that will only help us to understand part of how we produce different vowel sounds, because even though we've got a very rich note being produced by the vocal folds, it still doesn't tell us how we produce different notes. Now, in order to understand that, we're going to have to look at another property of sound, and this is called resonance. Now, in order to understand what resonance is all about, I'll point you to an experience that I suspect most of us have had. That if you take a bottle and you blow at the right angle a stream of air across the top of that bottle. Okay, you have to get the angle right, but what that does is it creates a note. Okay, now what's going on there? Well, as you blow across the top of the bottle, what you're doing is you're creating a kind of disturbance of the air molecules sitting there in the very neck of the bottle. Okay, the air that you're blowing will cause those air molecules inside just the top of the bottle to sort of bounce around inside, and they'll all bump into each other and generally get confused and mixed up. Now, given that they are bouncing around, they are vibrating, they're moving backwards and forwards with each other. And of course, it's pretty chaotic what's going on there, because as you're blowing air across that top of the bottle, everything is sort of like bumping into each other and vibrating at all sorts of different frequencies. So many frequencies that the actual sound that you hear is basically a hiss. A hiss is what we call white noise. White noise is virtually a load of frequencies all sounding together at the same time, and that's what the hiss noise is. But it's a very quiet sound, and it's not the sound that you actually hear when you blow across the neck of a bottle. You hear a far more louder and more clear sound. So what's that? Where's that sound coming from? Well, that's not the air molecules that bumping into each other in the neck of the bottle, or at the very top of the neck of the bottle. What sound you hear is the air molecules inside the bottle doing something which is peculiar to air which is confined in a particular space. That is, when you have a body of air inside a space, it has this property known as resonance, which means it will vibrate in sympathy to certain frequencies of vibration going on elsewhere. Okay. Now, as I said, In the neck of the bottle, your air molecules are bouncing around all over the place, producing lots of different frequencies. Some of those will be producing the very frequency that the body of air inside the bottle will resonate with. That is, they will come alive and start to vibrate along with those frequencies. And then because there's a bigger body of air there, and that's all vibrating at the same set of frequencies, then that note that you hear is much louder. Okay, so you're getting an amplification of some of the frequencies going on at the neck of the bottle in the air, the body of air inside the bottle. Okay, now different bodies of air have different resonant frequencies. They will vibrate in sympathy with different frequencies, and we can see that if you fill the bottle partly with water. What that does is when you blow across the top, you're still blowing the same amount and it's still causing the same amount of vibration at the top there, but that's going to produce a higher note because it's a different body of air. Basically, smaller bodies of air vibrate in sympathy or resonate with higher frequencies, faster vibrations, and therefore you hear a higher note the smaller the body of air. Okay, enough of the physics. We are now in a position to be able to understand how we produce vowels and how we produce different vowels. Yeah, let's go back to John again, this time the side of his head got open. Okay, and the thing to note here is that the cavities, the oral and nasal cavities, are just that. They're cavities, they're holes, and they are filled with air. Okay, and as we know, bodies of air have this property of resonating with vibrations. We also know that the vocal cords vibrate in very complicated ways, producing all sorts of different vibrations, different frequencies. And obviously then that is going to cause resonance inside the oral and nasal cavities of the air inside those cavities. And as we know, different shapes of bodies of air produce or resonate with different frequencies. And of course, we can change the shape of that body of air in the oral cavity simply by moving your tongue about. And that's exactly what we do when we produce different vowels. We shape the tongue in certain ways to create a different shape of the body of air inside the oral cavity, and that will produce a different sound because that body will resonate with some of the frequencies coming from the vocal folds. Okay, so basically, if you bunch your tongue up right towards the front part of your mouth, you'll get a vowel sound that sounds like E, E. Okay, because the body of air inside the oral cavity there is mostly at the back, and that vibrates in sympathy with the frequencies that produce that sound. On the other hand, if you bunch your tongue up towards the back of the oral cavity, you'll get a different vowel. You'll get oo, because there the frequencies that are resonated with in that shape of air inside your oral cavity pick out those particular frequencies coming from your vocal folds. Okay, so basically then we can describe vowels in terms of the position of the tongue inside the oral cavity. It doesn't touch any particular place, but it forms a particular shape. And basically the way we describe this is in terms of where the bulk of the tongue has to be in order to produce that different vowel. Now, in order to do this, we make a more schematic picture rather than using John to do it every time. We imagine the space inside your mouth as being something a bit more sort of chart-like. And this is the sort of shape that linguists tend to envisage as being the shape inside your mouth. Obviously, it's not particularly accurate, but it has a certain number of features which do kind of replicate what you've got inside your mouth. First of all, it's smaller at the bottom than it is at the top, and it's wider towards the front than it is towards the back. You get this kind of odd-looking rectangle type shape, and that's simply because your tongue is fixed to the bottom part of your mouth. That's where the root of your tongue is, down there, and therefore you can't move it so much as you can towards the top of your mouth. So that's why it's bigger towards the front and the top than it is towards the bottom. Okay. So this is the vowel space then. Okay, and as you can see, we've split it into segments. Okay, and we can name the different parts of this vowel space so that we can describe the place where the tongue is mostly situated, or the bulk of the tongue is mostly situated to produce different vowels. We have the front and the back part of the space, so we can call vowels front vowels or back vowels. And then there's a point in the middle of that which is called the centre, so there are central vowels. Representing the other dimension, the up and down kind of thing, we have open vowels at the bottom of this vowel space, and we have close vowels at the top of the vowel space. Okay, so we can call vowels open or close vowels. We have 2 points in between those, representing mid-open and mid-close vowels. Okay, so using these points of reference then, we can point out where the bulk of the tongue is to produce different vowels. Now, let's look at that in a little bit more detail. Let's start with an English vowel which is produced very high, so it's a very close vowel and towards the front. If you bulge your tongue up in that sort of position there, we get this E vowel. Now, what I'm doing here is using the IPA symbols that I use to represent these vowels. Okay. Now, the convention I'm using here is to put the IPA symbols inside square brackets to indicate that these are sounds, not letters of the alphabet or anything. You can see another aspect of the representation of vowels here, in as much as this vowel symbol, which is essentially a little letter for I, is also accompanied by 2 dots. These 2 dots indicate a feature of some vowels. As you are speakers of Hungarian, most of you at least, you all know that vowels come in 2 types. There are short vowels and there are long vowels. And in Hungarian, that's very systematic. For every short vowel, there is a long vowel equivalent of it. English is not quite as systematic as that. We do have long vowels and we do have short vowels, and E is a long vowel, hence this is why we represent it with those 2 dots following it. There's another fairly close but actually different vowel which is short, and that is also a front vowel and a fairly close vowel, but it's not quite so front and not quite so close as the E vowel. This vowel is I. It's a short vowel, okay, it doesn't have any length to it, I. But as you can see, it's not produced in exactly the same place either. If you move between the 2 vowels, between E, I, E, I, E, I, you can feel your tongue moving slightly. So this is very different from the Hungarian distinction between the long and the short vowels, because in Hungarian it's E, I, E, I. Okay, it's the same position. You don't move your tongue, you just add length to one of them. Okay, so in English then we have these 2 front close vowels, one a long one a short one, and slightly different in positions. Staying at the front, coming down towards the between the mid-close and mid-open, we have the E vowel. as in the word bet. That's also a short vowel, not a long vowel. We do have a long vowel around about there, but it's further towards the centre, and this is the vowel. Okay, the symbol obviously we use to represent this in the IPA has to be different from the one that we use in English spelling, because there are many different ways of spelling the sound, along with ER. We've got E's sometimes being used, and okay, we need a special symbol for it, and the way we represent this is like a back to front 3. No, that is a 3, sorry. Okay, so the vowel looks like that. Right down at the bottom, towards the front, we have the A vowel. Now, this is a very open vowel. It's so open, in fact, that in order to produce it, you have to lower your jaw a bit. So if you alternate between the E vowel and the A vowel, you'll notice that not only does your tongue move down, but your jaw actually opens further to be able to get your tongue so far down. So E, A, E, A, E, A involves a slight opening of the mouth. Okay, all of those then are the front vowels of English. As you can see, we've got 5 front vowels differing in their open and close positions, and some of them are perhaps a little further to the centre than the front. Similarly, we have back vowels. Okay, right at the back, but very high, in a close position, we have the oo vowel. Okay, this is similar in many respects to that front close vowel E. Okay, they're both fairly close, they're both long, and similarly as well, we also have another vowel which is produced fairly close to this one, but is a short one, and that is the U vowel. Okay, it's produced slightly more open and slightly more to the front than the U vowel, and it's short. Okay, so you can see this as the kind of the back equivalent of the I vowel. Okay, so we've got U and U. Coming down, further towards the mid-close position, we've got the O vowel. You may see this represented with different symbols. It depends on whose version of IPA you're looking at, but this is the one I've chosen to go for in this one, simply because it's easier to produce with the keyboard. You'll sometimes see it as a back-to-front A symbol, the kind of A that is the sort of the printed version, not with the hat on it, but just a line, and it's back to front. That's also a representation of the O vowel. Now, this one is an interesting vowel. It's a bit problematic for me because it's a vowel that I don't actually have. There's a distinction between the accents or the dialects of the north of England and the south of England, and one distinction is the lack or the presence of this particular vowel. Okay, in the south of England, the southern English dialect has this vowel. The northern British English dialect doesn't have it, and I come from around about the middle part of England, and in that part we are lumped in with the north, and so I don't have this vowel. I can try to produce it for you. To me it sounds very artificial, but you'll know what it is depending on how you've been taught to speak English. Most people, I think, second language learners of English are taught this southern British dialect, if you're taught the British one at all, not the American one. This is the vowel okay, as in but. In the north, we don't have that vowel at all. We use the vowel. So my pronunciation of this word would be but, not but. Okay, that to me sounds rather fake. But anyway, that's the way that probably most of you will pronounce it. You'll pronounce it differently from the foot vowel, uh, but as I say, I don't. And I'm going to get into trouble with that because every time I try to produce this vowel, either it will sound very fake or I'll forget to do it and use the vowel. But anyway, a southern British speaker will distinguish between this vowel and the vowel. So you've got the vowel. Similar height, we've got a long vowel, which is or. Okay, as in the word bought. Okay, that's a long vowel. And then right down at the bottom, the most open back vowel is this R vowel. Okay, so those are all of the back vowels. As you can see, we've got 6 of those. Yep, 6 of those. 5 front vowels, 6 back vowels. In the south of England, in the north of England, we've only got the 5 back vowels. Now, there's one more vowel that we haven't put on the chart yet, and that's this one here. And as you can see, this falls right in the center part of the vowel space. It's made by actually just relaxing your tongue and putting it in a neutral position, not drawing it any further down or pushing it further up, but just in this neutral position. And this is the vowel as you get in the word the. Now this happens to be a very special vowel in English, so special that we've actually got a name for it. We call this vowel schwa. And the reason why it's special can be seen in the pronunciation of the word the, because, as you probably know, there's another way to pronounce this word, and that is the. Okay, what's the difference between pronouncing the word the and the? Well, partly it's to do with the stress that's placed on the word. If you stress it, you get e, and if you don't stress it, you get the. Okay. So if I'm talking about the book, stressing the, okay, as opposed to the book. So whether you produce this vowel depends on the stress that's used. Okay, basically schwa is the unstressed vowel in British English, or well, in English in general. And basically, it's the way that you pronounce some vowels when you don't stress them. To see that, consider the pair of words photograph and photography. Okay, those two words differ in terms of where the stress falls in them. In photograph, the main stress is on the first vowel, pho, and then you get followed by an unstressed vowel, t, and then a slightly more stressed vowel, graph. Okay, note, pho, the main stress, is pronounced o. The unstressed t is pronounced schwa. Okay, and then you've got graph, a stressed vowel pronounced a. Compare that to photography, where the stress is in different places. In fact, the stress now, the main stress is on the second vowel, the one that was unstressed in photograph. For photography, the o vowel is stressed and it's pronounced o, not schwa. However, the vowel that was pronounced o in the other version, where the stress was on it, is now pronounced as f, photography. F, that is a schwa. So you can see, stress affects how you pronounce the vowels, and in English, unstressed vowels are pronounced with a schwa. Okay, now you may have noticed at the top of this slide, we've got the word monophthong. That's what all of these vowels are. They are monophthongs. This is a word taken from Greek, from mono meaning one and thong meaning sound. Okay, these are one sound vowels which are produced just by making one sound, be it a long or a short sound. Now that indicates that there are other vowels which are not monophthongs, and indeed there are. There are things called diphthongs from Greek dai meaning two and thong meaning sound. So these vowels are two sound vowels. Essentially, they are the vowel equivalent of the glides in consonants. They're things which start off as one thing but end up somewhere else and involve a movement from one position to another. That's why they're called diphthongs. Now, English has a number of these diphthongs. Hungarian, generally, most accents of Hungarian doesn't have uh, uh, any diphthongs at all. There are some dialects where you do. Over in the east, for example, you have some diphthongs used for. So, for example, the name Yoji in the East is often pronounced as Yaoji, and that involves a, a, a diphthong. Okay, so the diphthongs in English. Take the word late. There we've got a, which is a diphthong. We represent it by, in the IPA, a symbol which represents the starting place of the diphthong and a symbol which represents more or less the ending place. And on the vowel chart here, we can see it's represented as an arrow. So this vowel starts off somewhere close to where the vowel is. It's not exactly there. It's not exactly the same place. And it ends somewhere near the I vowel. So A, E, A. Okay. So we have that arrow going up from that front but central position between the mid and close and open up to a higher point of a close front vowel. Another similar one, in as much as they both have a similar ending point near the I, is the diphthong fly. We get in the word fly. That's I. It's starting off somewhere near the R sound, the R, and going up towards the E sound. So we're getting I. Okay, again, it's not exactly those two vowels it used. We do modify them slightly, but around about there. Another one which, again, is similar to these in as much as it has the same ending point is the one we get in the word like boy. That's oi. Starting off somewhere close to the or vowel and ending again with the e vowel. So oi. Okay. Now, all of these have in common that end point. They all move towards the front part of uh, uh, the, uh, the vowel space. They're often, therefore, referred to as fronting vowels. Okay, and as you can see, we've got three fronting diphthongs in English. We also have ones which move towards the back and specifically end near this O position. So take, for example, the vowel in the word go. That's O, starting near to schwa and ending somewhere closer to the U vowel. Okay, O. Another one which ends in the same sort of place is ow, as in the word now. That one starts off quite open and towards the front, near to the a position, but ending up near to the u position. Ow. Okay, those ones are known as backing diphthongs because they move towards the back. We then have three more, which all of which end towards the schwa vowel. Okay, take the vowel in here. That's ear, starting near to the e and ending somewhere near to the sound. Okay, the schwa. Another one, hair, as in air, starting this time a bit further down, nearer to the vowel, and ending again near the schwa vowel, air. Okay. Uh, there is one more. This one is slightly problematic, and it depends on who it was who taught you how to speak English as to whether or not you distinguish this vowel at all. It's the vowel that you get in a certain pronunciation of the word paw. Now, you can hear by the way I just pronounced it, I don't have this vowel. And in fact, most native English speakers don't have this vowel anymore. It's one that has been going out of the language for the past 50 years. It has been sort of like being replaced. And most people replace it with the vowel or, which isn't a which isn't a diphthong at all, but a monophthong. Okay, so most English speakers will pronounce this word as or, but you may have heard some English speakers pronouncing this word like poor, ua, which is, as we've got represented here, something that begins at a fairly high back position, u, and ending with the schwa, now, there may be people in the class that use this pronunciation, and that's because second language teaching tends to lag behind what's actually going on in the actual language itself. You often get foreign speakers of a language speaking with an accent which is at least 50 years out of date in terms of what's going on in the native language. So it depends on how old your teachers were as to whether or not they pronounce this word as poor or poor. Okay. Anyway, it's there. It's still part of the language of some dialects. Certain English speakers will still use it, but the vast majority of them these days don't. Given that all of these end up near to schwa, we refer to them as centering diphthongs. Okay. All in all, then, we've got what is that? That's 1, 2, 3, 4 plus 6, 10 diphthongs, and we've got, I believe, 10 of the other vowels. There are 20 diphthongs. 20 vowels in English. That's quite a lot of vowels as far as languages go. Hungarian, basically standard Hungarian, makes use of, I think it's 10 vowels. So it's a much smaller number of vowels in Hungarian than in English. English is actually quite complicated in terms of its vowel system. Okay, let's just summarize what we've said so far then. The vowels fall into two main groups, the monophthongs and the diphthongs, and that's to do with whether or not you've got a tongue movement in producing them. Without a tongue movement, you get a monophthong, and with a tongue movement, you get a diphthong. Okay, now the monophthongs can be categorized in terms of these different places where we produce them, the front versus the back and the open versus the close vowels, but they can also be distinguished in terms of whether they are long or short. Okay, and then of course we have this distinction used in terms of whether the vowels are stressed or unstressed. And in British English, the schwa vowel is used as an unstressed vowel. You never stress schwa. There are other unstressed vowels as well, which can also appear, but schwa is the one that is dedicated for unstressed vowels. The diphthongs are categorized in terms of what kind of movement of the tongue you've got, whether it's a rising or falling, or fronting or backing, or whether it's movement towards the center, centering vowels. Okay, that's enough for today, and I'll see you all in class. Bye.